Hello. Alright, today we are going to be learning about logarithmic properties, or properties and rules of logarithms. One of the problems when we start learning about logarithms is that there's this whole new jumble of characters and words that are hard to understand. They seem like they come out of nowhere. Like these set of rules, these are essential in understanding logarithms, but they can be hard to take in at first. So we're going to talk about the relationship between these rules and their exponential counterparts. So before we start with this, let's quickly go over the difference between exponential and logarithmic form. So with our base b, our a exponent, and n as our power, we can write logarithms as log base b of n equals a. We can switch this logarithm into exponential form and vice versa. We can change the exponential into a logarithmic form. In exponential form, it is b, your base, to the exponent a equals n, which we refer to as our power in logarithms. Now that we've reviewed exponential form and logarithmic form, let's get into the meat of it, the equations that we need to know. So you may be familiar with the exponential equation, x to the a times x to the b equals x to the a plus b. This is something you should have seen while studying exponents. Now the logarithmic equivalent is called the product rule. This is log of a times b equals log of a plus log of b. The parentheses I've put around the a. It's also fine if you don't put them around the value. These are the two different ways you can write it. Putting the parentheses around really just shows me exactly what the log is of. So there's our product rule, and it comes from this rule right here. As for our quotient rule, that comes from this division. There's also division here. This is part of why it's called the quotient rule. So x to the a divided by x to the b equals x to the a minus b. Now we can write this in logarithmic form of log of a over b equals log of a minus log of b. So the last rule that's super important to know is our power rule. So we know our power rule is x to the a, and this whole piece is to the b. So then once we apply the b in, we get x to the a times b. This can be transformed into our power rule for logarithms. That is, log of a to the b is the same thing as b times log of a. So this second part right down here, this is an extension of that. So let me grab my math work right here. We take this right here, log of x, all right, of x to the negative a. So remember that this becomes a fraction when the exponent is negative. So we can then take this negative a, pull it right out front, and multiply it to log base x of x, which we know as 1. So this is just 1 times negative a, which is where this comes in. One more thing we're going to touch upon is this right here. X to the 0 equals 1. This is something that at some point somebody probably just told you, that any value to the 0 power equals 1. Logarithms have a similar expression. It's called the logarithm of 1. This is log of any base of 1 will always equal 0. If this is a little confusing, you're welcome to try to switch it between exponential and logarithmic form. That may answer your question just a little bit about how these two things are equivalent. All right, now we're going to try an example. The example that we will be doing is 10 to the x equals 100. If you know that 100 is a perfect square, you can determine that 10 squared equals 100, which means x equals 2. That's not what we're working on right now. We're going to see if we can just try to manipulate this a little bit and practice one of our new rules. So first what we're going to do is we're going to change it into logarithmic form. you want to pause the video real quick and give it a try, go right ahead. Alright, so when I switched to logarithmic form, I got log base 10 of 100 equals x. So now that we have it in our logarithmic form, I think we should practice with the product rule. So I want to change this inside part and get it into factor it into two component parts. I chose 10 times 10, which equals 100. You could choose 2 times 50 or 5 times 20. Those also all work. So now what we're going to do is we're going to use the product rule. This is another chance for you to pause the video and give it a try on your own. Alright, so what I got was the correct answer. Log base 10 of 10 times 10 is the same thing as saying log base 10 of 10 plus log base 10 of 10 equals x. If you chose different values, such as 5 and 20, you should get log base 10 of 5 times 20, that's what the little dot means, it's times, equals log base 10 of 5 plus log base 10 of 20 equals x. So this top one right here with our 10s and this bottom one with our 5 and 20, these two statements are equivalent. We could change it from this form into this form and set these two equations equal to each other, and that would be a true statement. Now, a problem that a lot of people have with the logarithmic rules is switching up our multiplication sign and our positive sign. So sometimes people will write it this way. They'll write 5 plus 20 inside the first logarithm, and then in the second one they will write log base 10 of 5 times log base 10 of 20. I said our first one, but it actually really doesn't matter which one comes first, as long as you understand that these two are equivalent. These two, not equivalent. This is the wrong solution.